Last day, I think we started displacement time graphs and we drew all the displacement time graphs. Now I think that you have some kind of good understanding regarding displacement time graphs. At the last day, we completed around I think 20 graphs. I can't remember exactly. We completed all the displacement graphs. So by looking at the graphs, you should be able to predict the motion of the object. Then we know that displacement graph gradient represents velocity. Then based on the gradient, we are able to explain the displacement of the object and the velocity of the object. Then I think that section is completely covered. Now today we have to focus about velocity time graph, and today we will convert displacement time graphs into velocity time graph. If we have enough time, then also we convert velocity time graphs into displacement time graph. So then almost 65% motion graph section is completely covered. Then we can go to vectors, and if we have enough time for this month, we can start Newton laws. Right. Ah, right. Now I usually say that if you observe some kind of issues in my voice, then please just reply it as soon as possible. Right. Uh, yes. Mm, right. Give me a second. Give me a second. Now someone replied. Now last day at the very beginning of the class, did I explain? I explained what is displacement time graph. Did I roughly know that displacement time graph, and did I explain gradient of displacement time graph represents velocity? Did I give a note regarding that point? Gradient of displacement time graph represents velocity. And did I give a note, a small note, gradient tan theta equals velocity? Someone reply. Did I give a small note regarding that section? Someone reply quickly. Someone? Now I think that I gave, but I can't exactly remember. Please go through your notes and someone please clarify. Yeah, I gave a note. Then that is done. Right. Okay. Right. Now write down a point. Write down a point. When an object moving in a straight line. When object moving in a straight line, comma, a graph drawn between. A graph drawn between displacement and the time. Displacement and the time by measuring the displacements. By measuring the displacements corresponding to the time. Corresponding to the time is called as displacement time graph. Is called as displacement time graph. Already explained. Right. right? Now, next important point, write down next important point. The intercept, for interception, the intercept on y-axis, the interception on y-axis in a displacement time graph, in a displacement time graph, in a displacement time graph represents the displacement, represents the displacement, represents the displacement when t equals 0, when time equals 0, if not when t equals 0, when t equals 0, right? Now look here, right? Now look here. Now I think you guys can understand what it says. If I draw the displacement time graph, y-axis represents displacement, x-axis represents time, right? Now let's assume now there's a displacement some, then we can understand exactly at this point, exactly at this point, this graph cuts y-axis. Do you understand? This graph intersects with y-axis exactly at this point. I think in O level you learned that point we call as interception, intercept, right? Always understand exactly if a graph cuts the y-axis, that interception represents the displacement of the object when the time is 0. Do you understand? Because the point where the graph cuts the y-axis, we name it as interception. Always understand interception is the displacement when the time is 0. When t equals 0, displacement of the object is the interception. That's the idea. So if you want to draw this graph, you can draw below that point. But it's not compulsory. If you want, you can draw this graph for your understanding quickly. Then next point, that is also important point. Next point, we'll highlight the in the previous point. We'll highlight interception, highlight interception, displacement, t equals 0. The last point highlight interception, displacement, t equals 0. The next point, time may not, time may not be negative. Time may not be negative, but displacement may be positive or negative. But displacement may be positive or negative. Now we know that time can't be negative, right? And time is always some kind of positive value, right? Because time can't be negative. Minus 1 second, minus 2 second. If it happens, it seems like time traveling is possible. So therefore, time can't be negative. Always time is a positive value. That's why displacement time graph, there is no negative x-axis. Do you understand? But displacement can be positive or negative. That's why displacement time graph, there is positive y-axis as well as negative y-axis. Do you understand? Because all the previous graph that you driven last day, we could not find any graph having negative axis, negative time axis. Because time can't be negative. But last day we realized displacement can be positive or negative. From the point of consideration, if the displacement is to the right, we defined as positive displacement. From the point of consideration, if we measure the distance, if displacement to the negative opposite direction, That is what we call as negative displacement. That is also some kind of important point, right? Now again, we'll go with the summary. Summary means now you know how to argue by looking at the gradient. I hope that by looking at the gradient, I hope that now you can predict the velocity of the object if they have given displacement time graph. Very carefully listen. If they have given displacement time graph, by looking at the gradient, you are able to predict the velocity of the graph. I hope you guys can do it now. Now quickly we'll summarize it. Summarize it means we'll revise them again, and then we'll start doing a velocity time graph. Right. Okay. Now again we'll draw the graph quickly. We'll draw all the graphs again quickly, roughly. So we are not writing any points like we wrote on last day. The first graph. First graph. Now do with me. Right? Do with me. Do with me. First one. This is your graph. Now when you look at this graph, what can you say about the velocity? Displacement time graph, gradient represents velocity. Displacement time graph, gradient represents velocity. What can you say about the gradient? Gradient means I explained last day tan theta. Theta is 0. Now I don't explain how theta is 0. Last day detail explained. If you don't understand, please go through that last video. Now you know that theta 0, tan theta 0. Therefore we know that gradient 0. Therefore I can say velocity 0. When I look at this graph, I can tell that velocity is 0. Velocity is 0. Velocity exactly 0. Graph number 1. Right? And the displace, if you want to say displacement also 0, but most important thing is velocity is 0 and displacement also 0. Then graph number 2, graph number 1, graph number 2, graph number 3. What can I say about the displacement? Displacement is a positive value. Now you know why. Displacement is a positive value. It's a positive value, but I'm much interested velocity, right? Now anyone can tell what will happen to the displacement by looking at the y-axis, but I'm much interested with the velocity. The displacement is positive. What can you say about the velocity? Velocity is again 0, because always take the gradient, because in displacement time graph, gradient is velocity. Gradient is velocity. Now gradient, if I draw a tangent line, gradient is 0. Last I explained. Then here is also velocity is 0. The displacement is positive displacement. Displacement is positive. Velocity is 0. Second one. The third graph. In the third graph, again displacement is negative. Anyone can say that displacement is negative. Displacement is negative. What can you say about the velocity? Velocity is 0 again. Gradient 0, velocity is 0. Quickly, don't waste your time. Quickly, do with me. Quickly do with me. Graph number 4. Fourth one. Fourth one. Fourth one. Now, what can you say about the velocity? Now, anyone can say what can it, okay. We'll hereafter we'll decide this way. First of all, tell about what's happening to the displacement. Then tell what's happening to the velocity. But I am much interested with what's happening to the velocity. That's very important idea. At every graph, you should be able to predict what's happening to the velocity of the object by looking at the graph. Now, someone tell me what's happening to the displacement. Positive displacement increases. Right? Positive displacement increases. Right? Positive displacement increases. Right? Positive displacement increases. What can you say about the velocity? If you want to know about the velocity, always check the gradient. Now, when I look at the gradient, what can you say about this angle? What can you say about the angle? With the time, first of all, tell me everyone reply in chat box. What is the angle? What is the angle? Reply in chat box. What is the angle? Acute angle. With the time, acute angle is constant. With the time, acute angle is constant. Last I explained detailedly. With the time, acute angle is constant. Acute means I told you that positive tan theta, that means positive gradient. Always understand acute means positive gradient. Obtuse angle means negative gradient. Always understand acute angle means always positive gradient. Obtuse angle means always negative gradient. Suppose if the acute angle is increasing, positive gradient increasing. If the acute angle is decreasing, positive gradient decreasing. Suppose if the angle is obtuse, very carefully listen. Suppose if the angle is obtuse, if the obtuse angle is increasing, negative gradient decreasing. If the obtuse angle is decreasing, negative gradient increasing. Do you understand? Then constant, acute angle constant. Acute angle constant means acute means positive gradient. Acute means positive gradient constant. ST graph gradient means velocity. ST graph gradient means velocity. Then I can say that positive velocity constant. Positive velocity constant. Graph number 4. Graph number 5. Fifth one. Graph number 5. If you have any issue, any problem, ask from me. Now, what can you say about the displacement? By looking at the y-axis, you can easily predict the displacement. Positive displacement increasing, right? With the time, positive displacement is increasing, right? Positive displacement increasing. What can you say about the velocity? What can you say about the velocity? Check about the gradient. Check the angle. Angle is acute. Very carefully when you listen, you will understand that with the time, what will happen for the acute angle? Acute angle increases with the time. Acute angle increases with the time. If acute angle is increasing with the time, what can you say about the velocity? Acute angle increasing. That means acute means a positive gradient increasing. Acute angle increasing means positive gradient increasing. Positive gradient increasing means positive velocity increasing. Gradient is velocity. Now here positive velocity constant, here positive velocity increasing. Graph number 6. Graph number 6. 6th one. Now what can you say about the displacement? Again, positive displacement increasing. Positive displacement increasing. What can you say about the velocity? Angle is acute. Acute angle is decreasing. Acute angle decreasing means positive gradient decreasing. Positive gradient decreasing means positive velocity decreasing. Positive velocity decreasing. Graph number 7. Now this time the angle is obtuse. Now please tell me now, what is happening to the displacement? With the time, positive displacement is decreasing. With the time, positive displacement decreasing. What can you say about the velocity? Now angle is obtuse. Throughout the time, throughout the motion, obtuse angle is constant. Obtuse angle means I told you that negative gradient. Can remember, obtuse angle means always understand negative gradient. Obtuse angle is constant. Negative gradient constant. Negative gradient constant in the sense negative velocity constant. Negative velocity constant. Graph number 8. Now, graphs like this sometimes not only you, sometimes for me also, it's somewhat difficult to predict, difficult to understand what's happening to the angle. By looking at the graph, I can say the angle is obtuse, but it takes some time to understand whether obtuse angle is decreasing or obtuse angle is increasing. So for me also, it takes some time. Sometimes suddenly, when I look diagram, when I look at a diagram, sometimes I can't also suddenly I can't think what's happening, right? It's a obtuse angle. We know it's an obtuse angle. What will happen for this obtuse angle? Obtuse angle. Now we know that with the time, obtuse angle is, I can draw and I can show that, but last day I did that. That's why without drawing, I'm explaining. If not, I can take 3 points on the graph and I can show it again. But I assume that you guys have that knowledge. If in case if you don't understand what I'm doing here, then you can go back to the theory note and you can understand obtuse angle has decreased. If not, you have the recordings also. You can go to the recordings. That's why I don't explain much detail because already it is explained. Already I explained these things, but again for a revision, I am explaining. Already I explained all these graphs, but for a revision, I'm explaining, right? Then you will understand that with the time obtuse angle is decreasing. Obtuse angle decreasing means negative gradient increasing. I told you. Obtuse angle decreasing means negative gradient increasing. Negative gradient increasing means understand negative velocity increasing. Negative velocity increasing. Now here, what can we say about the displacement? Positive displacement decreasing. Now raise your hands. Up to now, everything is very clear. Raise your hands if you understood up to now. Everything very clear. Raise your hands. Right. Graph number 9. Ninth one. Now, in this graph also, positive displacement decreases. What can you say about the velocity? Again, angle is obtuse. When you carefully look at the obtuse angle, with the time, obtuse angle is increasing. Obtuse angle increasing means negative gradient decreasing. Obtuse angle increasing means negative gradient decreasing. Therefore, negative velocity decreasing. Negative velocity decreasing. Graph number 10. 10th one. Now here negative velocity increases, sorry, negative displacement increases. Displacement increases in the negative direction. Negative displacement increases. What can you say about the velocity? Angle is obtuse. Obtuse angle constant. Negative gradient constant. Negative velocity constant. Negative velocity constant. Right? Always check the gradient, not the y-axis when you are understanding about velocity. If you want to judge about the velocity of the object, always check the gradient. Mistakenly, please don't check what's happening in the y-axis. Because displacement time graph, y-axis represents displacement. Gradient of the graph only represents velocity. Therefore, understand that idea. Sometimes you might do some mistakes because still we are learning about displacement time graph. So after I teach this velocity time graphs also, then so you will get more confusion because displacement time graph gradient is velocity, velocity time graph gradient is acceleration. In displacement time graph, gradient is the velocity, but in velocity time graph, y-axis is velocity. So therefore, very calmly, patiently learn what I am saying. If not, you will confuse in the upcoming sections. Next one, next one, 11th one, 11th one, graph number 11. Graph number 11, that is now in this case also negative displacement increases. With the time, negative displacement increases. And also the check the gradient. Obtuse angle is actually obtuse angle is decreasing. Obtuse angle is decreasing. Obtuse angle decreases means negative gradient increases, negative velocity increases. Negative velocity increases. Graph number 12. Now in this case also negative displacement increases. Obtuse angle. Obtuse angle is increasing. Negative gradient decreasing. Negative velocity decreasing. Graph number 13. I assume that you guys have no confusion regarding these graphs. I think in that way. If you have any issues, then please reply in the chat box. So if not, after class finishes, put a voice record or just a text message. Then I will go through it and I will explain. Graph number 13. In here, you will understand that negative displacement decreasing. Negative displacement decreasing. Negative displacement decreasing. What can you say about the angle? Angle is acute angle. Am I correct? This angle is acute angle. Acute angle constant. Acute angle constant means positive gradient constant, positive velocity constant. Positive velocity constant. Graph number 14. If you understood this idea, then that's it. Any graph in your syllabus, you will be able to understand. Right? Therefore, please, my advice is some method seems like very easy, but don't go with learn by heart methods. That's my advice. Because here, physics is not a subject that we learn by heart. Chemistry, you can learn by heart and you can get a result. In biology, obviously, but when it comes to maths and especially physics, even combined maths also, if you have done very similar types of questions and when you go to the exam, you are able to score at least 60-65% of that question. But when it comes to physics subject, understand physics is not a subject that we do by learn by heart methods. Understand that idea. By learn by heart methods or by remembering the equations, you will not able to do any question. You will understand in upcoming chapters, right? So therefore, always think why this happens, how to apply. Always think the logic behind every question. Why this graph is in this way, right? So that's the best way of learning. Then even in an exam, whatever the way they ask the question, you will get answer. You will able to answer. So therefore, never go with learn by heart methods. In physics, next important thing is now, especially students like you, short methods. Now some teachers also they really mislead you by mentioning about short methods. Now, for especially MCQs, there are many short methods, and they think that they say that. Now, they say that they market themselves by mentioning they can teach short methods to get the answers. But always understand, subject like physics, there are no short methods. But one is true. With every question that we practiced at the end of the section, we know how each question works. If you properly followed what I said for last 2-3 months, you also sometimes agree with me. In physics subject, there is no short method. But when we practice many questions, then we will get an understanding that this is how questions are asked. This is the pattern that we want to apply to theory. You will get some kind of pattern. Some people teach that pattern as short method. That's the wrong thing. So therefore, understand that there is no short methods, right? That's the thing. But sometimes, next thing, some people justify they teach short methods by mentioning now. What we say short method now? Short road means what now? Let's say now the distance from now. Now there are two possible roads to move from A to B. So one road is long, other road is very short. So therefore, we say that that road is short road, this one is long road. Very similar manner, short method means what? Short method means if we can get the answer by doing a very few amount of steps, then we say that it's a short method, right? If you take a long time, if you take long steps to complete and get the answer, then we say it's a long method. But understand that comes you that now with the practice, what I want to say is with the practice, you will be able to do whatever the given question within minimum number of steps. In the very beginning of the linear motion question, sometimes you might have followed many steps, but after you understood that section entirely, after you practiced well, sometimes you know that I don't need to apply this step, I don't apply this step. Directly I can substitute and get the answer. So therefore, in physics subject, there is no short methods. Understand, with the practice, we get some kind of pattern. So that is what people say are short methods, but they are not short methods. Do you understand what I'm saying? I hope you understand what I'm saying. Okay, anyways. Right. Okay. Right. Uh right. Next graph. This one. Now here is also negative displacement decreases. Negative displacement decreases. Now again angle is acute angle. When you carefully look, when you look here, the angle is acute angle. What's happened to the acute angle? That acute angle is decreasing. That acute angle is decreasing. Am I correct? Then acute angle decreases means positive gradient decreases. Therefore, positive velocity also decreases. Positive velocity decreases. Positive velocity decreases. Right? The last few graphs. Okay. Last few graphs. Then we can start velocity time graph. Then next one is 15. This one. The last graph, I think. Now in here again negative displacement decreasing. Angle is again acute, but this time acute angle is increasing. Acute angle increasing means positive gradient increasing, positive velocity. That's it. Now raise your hands. Up to now, everything is very clear. Already learned section on last day, but again I revised quickly. Raise your hands. Whatever I taught up to now, did you understand? If you understood, raise your hands. Right? Okay. Now, still drawing. Raise your hands. How many of you finished drawing these diagrams? Finished drawing. Raise your hands. Finished. Finished drawing. Right. Okay. Uh, Now, before going to the velocity time graph, last important point, write down last important point. Information, write down information gathered from a ST graph. Information gathered from a ST graph. Information gathered from a ST graph. Number one, write down. Put number one and write down. Number one, variation of displacement with time. Variation of displacement with time. First one is variation of displacement with time. Inside the bracket from y-axis. Inside the bracket from y-axis. Number two, variation of velocity. Variation of velocity variation of velocity with time. Variation of velocity with time inside the bracket from the gradient. From the gradient. Any ST graph, you will understand that if you want to understand what's happening to the displacement with the time, we check the y-axis. Here, when we check the y-axis with the time, with the time, with the time, negative displacement increasing. So therefore, if you want to understand the displacement of the object, we check the y-axis of ST graph. Right here, what happened to the y-axis with the time? With the time, what's happened to the y-axis? Positive displacement increased. So therefore, understand displacement time graph from the y-axis, we can understand the variation of displacement of the object with the time. Second one is velocity. Displacement time graph with the time, by looking at the gradient of the graph, we can understand the velocity, right? Now one asks that how to find the angle increasing or decreasing, what direction? In this direction. Always from this point, always been from here to here. If you are moving this direction, what's happened to the angle? That's what always you want to think. If you are moving along this time axis to the right side direction, what happened to the angle? Then put your main topic, velocity time graph. Main topic, velocity time graph. Main topic, velocity time graph. I will explain, don't worry, I will explain. Write down. A graph drawn by, write down, a point, a graph drawn by measuring the velocity with time. Measuring the velocity with time. When you are writing, understand, write down. A graph drawn by measuring the velocity with time of an object, of an object, of an object moving in a straight line. Moving in a straight line. Moving in a straight line is called as is called as velocity time graph. Velocity time graph. Next point. Next point. Velocity to one direction. Velocity to one direction. Inside the bracket, right side direction. Inside the bracket, right side direction. Close the bracket. Is considered as positive. Positive. And the velocity is to the other direction. And the velocity is to the other direction. And the velocity to the other direction. Inside the bracket, left side direction. Inside the bracket, left side direction. Close the bracket. Is considered as negative. Is considered as negative. Don't worry, I will explain all the important points. Don't worry, we'll write the note first. Is considered as negative. Next one, important points. Put important, under important, take a red color and write down important, red color pen. The intercept, if not interception, right? The intercept on y-axis. The intercept on y-axis in a velocity time graph, V hyphen T graph. the intercept on y-axis in a velocity time graph denotes the velocity at denotes the velocity at denotes the velocity at t equals 0. Denotes the velocity at t equals 0. Next point is also red color pen. X coordinates represent the time. On x axis represent the time. And y coordinates represent the velocity. From y axis represents the velocity. And y coordinate represents the velocity. If not, you can write down y axis represents the velocity corresponding to each time. Corresponding to each time. Corresponding to each time. Corresponding to each time. Okay. Yes. Now subtopic gradient of a velocity time graph. Put your subtopic gradient of a velocity time graph. Gradient of a velocity time graph. Gradient of a velocity time graph. Right? Yes. And now we know that now. Let's consider motion of an object. Now when we consider motion of an object, we know that let's say here that's a car. That car is increasing its velocity with the time. Then right now you are keeping some kind of track record every 1 second. If not every single second, uh, you detect the velocity of the car. For example, let's say when t equals 0, car was at rest. Then when t equals 0, velocity of the car is 0. Then when t equals 1 second, there's some kind of device. That device directly shows the velocity. Okay. When t equals 1 second, velocity of the car is 10 ms minus 1. When t equals 2 second, velocity of the car is 25 ms minus 1. When t equals 5 second, velocity of the car is 100 ms minus 1. When t equals 100 second, velocity of the car is 400 ms minus 1, whatever. Then you have the variation of velocity with the time. Every time, every time you have the corresponding velocities. Am I correct? Every single second, t equals 1, t equals 2, t equals 3, every single time every time you have the corresponding velocity of the vehicle. Then if you plot a graph with the variation of velocity with time, considering y-axis as our velocity vector, considering x-axis as our time, then that graph is we call as velocity time graph, right? So therefore, velocity time graph represents the variation of velocity with time. How velocity varies with the time. That is what we call as velocity time graph. Now, if I do the velocity time graph, right? Now I'm drawing a velocity time graph. So you also draw together with me. Y-axis is velocity. You want to understand velocity is a vector. Velocity is a vector. It is having not only the magnitude but also it is having direction as well. Then y-axis represents velocity. That means we need to consider positive y-axis as well as sometimes we need to consider negative y-axis because velocity is a vector. Therefore, velocity has a direction, positive direction and negative direction. Now, very similar idea. If the if the velocity of the vehicle, if the velocity of the object is the right side direction, If the velocity of the object is to the right side direction, we say positive velocities. Last day also explained. If the velocity of the object is to the left side direction, we say that velocities are negative velocities, negative values. For example, let's say that a car is moving with the velocity of minus 50 ms minus 1, minus 50 ms minus 1. Then you can come to a conclusion that a minus 50 ms minus 1, magnitude of the velocity is 50 ms minus 1, but the direction is to the left side direction. That's the idea, right? If I draw velocity time graph, this is my VT graph. Now I need to understand gradient of velocity time graph represents which physical quantity. That's the main important thing I want to confirm. Now displacement time graph gradient represents velocity. We learned that idea. Displacement time graph y-axis represents displacement. When it comes to VT graph, y-axis represents velocity, gradient represents the physical quantity. That's we are going to find now. Now let's see that I consider a point. Let's say this point is point capital. I see this point is point capital A or something else. This point is point capital A. Point capital A. Now I think you can remember how we define gradient. Now I want to find the gradient at point A on the graph. If I want to find the gradient at point A on the graph, you want to draw a tangent line passing through point A. Draw a tangent line passing through point A. If I draw a tangent line passing through point A, this is my tangent line. Tangent line passing through point A. I think you can see the line, the tangent line. And then start measuring the angle from positive x-axis to the tangent line in anti-clockwise direction. Start measuring the angle from positive x-axis to the positive x-axis to the tangent line in anti-clockwise direction. That angle, tan value of that angle is we say as gradient. Gradient means tan theta. Okay, gradient means tan theta. Right. Okay. Then I can say that gradient in VT graph. I can write down. Uh, gradient in velocity time graph. Velocity time graph. Gradient means usually simple limb. Simple limb equals simple limb equals. So you also keep on when I explain, if you feel when I explain, you want to listen as well, and also because as it is an online class, you want to somehow quickly write down as well. Don't always give 100% attention only to write down, but listening is number one. Number two is writing, because even because you have recording option also, but even you miss listening, you can watch it. But listening is number one, right? The simple limb equals tan theta. Simple limb equals tan theta. Tan theta. I hope you understood up to now. There is no issues because very similar thing we learned in displacement time graph as well. Now the problem is I want to understand gradient in velocity time graph represents which physical quantity. Now tan theta means we know that delta y over delta x. Delta y means we know y2 minus y1 over x2 minus x1. Am I correct? So therefore I thought of consider two coordinates on this tangent line. My target is finding the gradient at point capital A on the graph. So I thought of consider two coordinates on this tangent line. Let's say this coordinate is coordinate 1, this point and this point. And I know the coordinates at this point. The coordinates at this point is x1 comma y1, x1 comma y1, and the coordinates of this point, that is x2 comma y2, x2 comma y2. Then horizontal distance from y-axis is simple x1. Am I correct? This is simple x1, simple x1. Vertical distance to this point is y1 from x-axis. This is y1. This is y1, right? Right. Now, coordinates of this point is x2 and y2. That means horizontal distance to this point from y-axis is x2. Horizontal distance to this point from y-axis is x2. This will be x2. Right. Now, what is y2? Vertical distance to this point from x-axis. Vertical distance to this point from x-axis, that is y2. That is y2. That is y2. Y2. Then now I take this point, these 2 points as if I consider these 2 points as point P and point Q. This point is point P. This point is point P. This point is, let's say, point Q. If I consider a right angle triangle PQN, PQN capital R. If I consider right angle triangle PQN capital R. Right. This right angle triangle PQ capital R. For your understanding, I draw this PQR triangle outside for your understanding. Then this is my PQR triangle. Right. P Q capital R. Now I know that this angle is theta, then you know this angle also should be theta. All levels, what is the angle that we call, I mean, this angle equal? What is the name that we call for these angles? In all levels, you might have learned. What is the name that we call for these angles? What is the name that we call for those angles? Reply. What is the name that we call for those angles? Yeah, corresponding angles. Yeah, that's the thing. Corresponding angles. Then I know this angle is also theta. This angle is theta. Now, the distance to point capital P from y-axis is x1. Distance to point capital Q from y-axis is, that is x2. What is the distance between P and R? Distance between P and R will be x2 minus x1. This gap is x2 minus x1. And if I consider PR means x2 minus x1, x2 minus x1. And also, if you consider distance to point capital R, vertical distance to point capital R is y1, vertical distance to point capital Q is y2, then you will understand QR will be y2 minus y1. This QR will be y2 minus y1. Then I can write down the gradient means tan theta. Tan theta means opposite over adjacent. Tan theta means opposite over adjacent. Therefore, I can say that gradient equals opposite y2 minus y1. Do you understand? Y2 minus y1. We need to understand y-axis represents velocity. X-axis represents time. Then y2 minus y1. If not, I can write down this as v2 minus v1. Why? Because y-axis is velocity. Coordinate of this point is time t2, velocity v2. Coordinate of this point is x1 comma y1 means time x-axis t1 comma v1. I hope you understand what I'm saying. t1 comma v1. Coordinate of this point is x2 comma y2. If not, time is t2. X-axis is time now. X means time. t2 comma y means velocity v2. Therefore, I can write down tan theta means v2 minus v1, v2 minus v1 over time. X2 minus x1 means t2 minus t1. T2 minus T1. Gradient. The gradient equals V2 minus V1 means change in velocity. Therefore, I can say delta V. T2 minus T1 means change in time, delta T. And now we can come to a conclusion that gradient represents rate of change in velocity. Always understand, velocity time graph gradient represents rate of change in velocity. Now we know that. What does it mean by rate of change in velocity? We call rate of change velocity as what? Rate of change of velocity we called as acceleration. Acceleration. And then we can say that therefore gradient represents acceleration. This is acceleration. Acceleration. Copy down quickly. I hope you understood up to here. Copy down quickly. Quickly copy down. If you finish copying, raise your hands quickly. If you finish copying, raise your hands. Right? If you finish copying, raise your hands. Then I can discuss next section. Right? Done. Okay. Then right. Red color important. Red color important. In a velocity time graph, in a velocity time graph, in a velocity time graph, gradient, gradient represents acceleration. In a velocity time graph, gradient represents acceleration. Highlights, very important point. In velocity time graph, gradient represents acceleration. Right? Okay. Now again we have to draw the graphs again and we want to understand what's happening to the graphs. Right? Yes, again we'll start drawing the graphs. Right. We'll draw it. Graph number 1. Now I think now conclusion is, look here, the conclusion. Displacement time graph. Y-axis represents displacement, x-axis time, gradient of displacement time graph represents velocity. When it comes to velocity time graph, gradient of y-axis of the velocity time graph represents velocity. X-axis of VT graph represents time. Gradient of velocity time graph represents acceleration. That's the important thing, right? And now we'll draw a set of velocity time graphs and we'll understand what's happening to the velocity with the time. Right. First graph. First graph. Right. First one. Yes, now because tute also same thing is there. Therefore, you have to complete now. After class finishes, you can complete the tute, right? Do you understand? Therefore, theory note this should be written in your theory note also. But after class finishes, you can copy in your tute also. Because import theory book is important. Note is important, right? Yes. First one. First graph. Y-axis velocity, x-axis time. Time. Your graph is this is your graph. Uh, okay. Then this time velocity represents y-axis. Y-axis represents velocity. Gradient of VT graph represents acceleration. Do you understand? Very carefully understand that idea. And now what can you say about the velocity? Velocity is zero. Look at the y-axis. Okay. Now if you want to understand about velocity, look at the y-axis. Look at the y-axis. Velocity is zero. Velocity is zero. Right. Graph number two. Graph number two. What can you say about the velocity? What can you say about the velocity? Graph number two. If you want to understand about the velocity, look at the y-axis. What's happening in the y-axis? Y-axis represents velocity. Y-axis represents velocity. Positive velocity constant. Look here. Positive velocity constant. Do you understand? Positive velocity constant. Here velocity is zero. Gradient of VT graph. Velocity time graph gradient is acceleration. First graph, what can we say about the gradient? Gradient is zero. In the first graph, what can you say about the acceleration? Velocity zero means acceleration is also zero. Velocity zero means acceleration is also zero. Again, the write down acceleration is zero. Gradient zero. Acceleration is also zero. Third one. So we'll take a break at 8:35, 8:40. We'll take a break and because we want to finish this section quickly and we want to start vectors. At least we should start Newton laws. Do you understand what I'm saying? Next one. V. Uh, this time. This graph. This one. Now in this case, third graph. What can you say about the third graph? Now, if we want to judge about the velocity, if we want to judge about the velocity, what can you say about the velocity? Velocity is negative. Do you understand? Look at the y-axis. Negative velocity constant. Negative velocity constant with the time. Throughout the time, negative velocity remains constant. When the time is 1 second also, velocity is negative 5. When the time is 2 second also, velocity is negative 5. When the velocity is 3 second also, velocity is negative 5. So therefore, with the time, negative velocity constant. Negative velocity constant. Negative velocity constant. Again, gradient of the graph is 0. Gradient of VT graph is acceleration. Acceleration is 0. 0. Graph of, if you don't understand, please, now I think I replied your questions, okay, now, because with the time now, you asked that how do we understand whether the angle is increasing or decreasing in what direction? Always to the right side direction. Just think you are walking on the right side of the timeline. You are walking on the right side of the time axis. Then understand what will happen for the angle. That's the idea. Therefore, in case if you have an issue, put in the chat box. So if not, separately after class finishes, send us a voice record or text message. Okay. Now I hope that all of you understand. In case most of you don't understand, then I will have some different ways of explaining the ideas. It's a headache. It's not headache, huh? Because I don't agree. It seems like headache because it's very interesting. Because after this, we are converting ST graph into VT graph. Then we will do 20 questions. Then people who understand the logic, it seems like interesting. I don't know how others feel about that, but it's really interesting. Now we will do. I think today we can do it. Today we'll do it. Today we'll convert them. Then graph number 4. Graph number 4 is this one. Now velocity. What's happened to the velocity? Positive velocity increases. Now, if you want to understand now in ST graph, if you want to understand about the velocity, we check the gradient in ST graph. In VT graph, if you want to understand the velocity, check the y-axis. Now, what happens now? Now, most of students, what they do, because they have the exposure, checking the gradient in ST graph to find velocity. Because they covered ST graph right now, because now they know, now they already they now, if they want to find the velocity, they check the gradient in histogram. Now, when it comes to velocity time graph also, if we want to find the velocity, again they check the gradient. But you should understand that now gradient is not velocity in VT graph. Now gradient is acceleration. If we want to check about the velocity, check the y-axis. Check the y-axis. In VT graph, if you want to check the variation of velocity, check the y-axis. In ST graph, if you want to check the variation of velocity, check the gradient. Now, in this case, now in here, what's happening to the velocity? Positive velocity. Positive velocity increases. Positive velocity increases. What can you say about the acceleration? Gradient of VT graph is acceleration. Acute angle. Constant acute angle means positive gradient constant. Now this time gradient is acceleration. Positive acceleration constant. Positive acceleration constant. Then graph number 5. After the break, we'll convert ST into VT. Then we'll finish this and we'll take a break. Now here, velocity. Positive velocity increases. Positive velocity increases. Gradient. Acceleration. Check the gradient. Acute angle increases. Positive gradient increases. Positive acceleration increases. Positive acceleration increases. Graph number 6. Now here, velocity. Positive velocity increases. Acceleration. Gradient. Acute angle. Acute angle is decreasing. Acute angle decreases. Positive gradient decreases. Gradient is acceleration. Positive acceleration decreases. Positive acceleration decreases. This one, positive velocity decreases. With the time, positive velocity decreases. And gradient is angle is obtuse. Obtuse angle constant. Negative obtuse angle means negative gradient. Negative gradient constant. That means negative acceleration constant. Negative acceleration constant. Graph number 8. 8. Now in this case, positive velocity decreases. Obtuse angle is decreasing. Obtuse angle decreasing. If your obtuse angle is decreasing, negative gradient increasing. Negative acceleration increasing. Negative acceleration increasing. Ninth one. Ninth one. Now in this case again positive velocity decreases. Look at the y-axis. Positive velocity decreases. Angle, obtuse angle. Angle is obtuse angle. Obtuse angle is increasing. Obtuse angle increases means negative gradient decreases. Negative acceleration decreases. Negative acceleration decreases. Graph number 10. Tenth one. Uh, Negative velocity increases. Y-axis. Y-axis. Negative velocity increases. Obtuse angle constant. Obtuse angle constant. So when you are going along the time axis, you'll understand obtuse angle constant. Negative gradient constant, negative acceleration constant. Negative acceleration constant. Of number 11. 11th one. Now again, negative velocity increases. Y-axis, look here. Y-axis, negative velocity increases. Obtuse angle. This time obtuse angle is decreasing. Obtuse angle decreasing means negative gradient increasing, negative acceleration increasing. Graph number 12. Graph number 12. Now here, right here, again negative velocity increasing, y-axis, negative velocity increasing. Acceleration, obtuse angle is increasing. Obtuse angle increasing, negative gradient decreasing, negative acceleration decreasing. Graph number 13, 14, 15. We have three more graphs, then we'll take a break. Then after the break, we'll do the remaining. We'll take a break. Okay. Now before that, we have three more graphs to do. 13. Graph number 13. Graph number 13. 12, 13. Graph number 13. This is the graph. Uh, Graph number 13. I will do 14, also 14, 15. 13, 14. And 15. Now 13, again, look here what's happening. Look at the y-axis. If you want to understand about what's happening to the velocity with the time, just check the y-axis. When you check the y-axis, tell me what's happening to the y-axis with the time. With the time, what will happen to the velocity? Velocity, negative velocity decreasing. With the time, negative velocity decreasing, right? Am I correct? Look here. When 1 second, negative velocity will be here, minus 5. When the time is 2 seconds, negative velocity will be here, minus 4. When time is 3 seconds, velocity will be 3. And when the time increases, negative velocity decreasing. I hope you understand what I'm saying. Negative velocity decreasing. Acute angle, if you want to find the acceleration, acute angle, acute angle constant. So therefore, positive acceleration constant. Then here, negative velocity again decreasing. With the time, same idea, negative velocity decreasing. Negative velocity decreasing, acute angle. Acceleration is acute angle. Acute angle is decreasing. Acute angle decreasing means positive gradient decreasing, positive acceleration decreasing. The last graph, negative velocity again decreasing, and negative velocity decreasing. That means acceleration angle is acute angle is increasing, positive acceleration increasing. That's it. Now, genuinely raise your hands. We discussed ST graphs detailing because I should explain detailing ST graphs. Then only you will get a good exposure to the graphs. So last week entirely what have we done? Last week we discussed about ST graphs. But based on that knowledge, how to argue, y-axis represents what, x-axis means what, gradient means what, how to argue, what's happening to the y-axis, what will happen for the gradient. Based on that knowledge, you can easily understand the weighty graphs. A weighty graph's only difference is y-axis is v, gradient is acceleration. Raise your hands, whatever we learned up to now, genuinely if you understood. Raise your hands. If you understood genuinely, raise your hands. Right, okay. The time is exactly 8:35, come at 8:45. We'll take 10 minutes break, wash your face and drink something and come. Okay, we'll start at 8:45. Then we'll start that converting ST into VT, then VT to ST, then it's all about questions. Okay, right, we'll take a break and come. Come at 8:45. Right. Right. Now, one confirm, please. If you can hear me speaking, one confirm quickly. Right. Now again, okay. Now that's it. Now we know what is displacement time graph. We know what is velocity time graph. Now, usually in MCQs, most they ask that they ask us to convert given displacement time graph into velocity time graph. If you check the past paper MCQs related to this section, motion graph section, usually they give displacement time graph. Mostly we want to convert to velocity time graph. If not, they give VT graph, velocity time graph, and we want to convert into displacement time graph. Now, before going to that, one last time I take some time and I explain what's happening. Now I'm telling you when time increases, positive velocity increases, positive velocity decreases. Now sometimes some students they have no right understanding about that. Therefore, I take some time and I take 2 3 graphs and I explain what's happening there. Right? Then we'll go to the conversion part. That is the important part today. Now look here. Let's take one of the graphs. Now this graph number 11. Now graph number 11, I told you that it's VT graph. Y-axis is velocity, x-axis that is time. Then in a VT graph, velocity is represented by y-axis. Am I correct? If the y-axis is velocity graph, if y-axis is velocity, values in y-axis, values in y-axis, values in y-axis represents velocity. For example, this point is plus 5 ms minus 1. This point is plus 2 ms minus 1. This point is origin, that means 0 ms minus 1. This point is minus 1, ms minus 1, minus 2, minus 3, minus 4. Y-axis represents velocity. X-axis is time axis. 1 second, 2 second, 3 second, 4 second, 5 second, 6 second. Now when the time is 0, now normally all these graphs, how I explain two important factors. All these graphs, what happened to the velocity, then what happened to the acceleration. Blue color pen, I represented, I marked what happened to the velocity. Red color pen, I marked what happened to the acceleration. And throughout the graphs, I mentioned positive velocity increases, positive velocity decreases, positive velocity constant, positive acceleration constant, positive acceleration increases, negative acceleration decreases. When I deeply explain this, look here. When I take this graph, with the time, when that object is moving, when the object is moving under, when the object is under motion, time is increasing. T equals 1 second, T equals time is increasing. Because I'm talking with you right now, time is increasing. Now time is 8:30. We started the class again at 8:45. The time is roughly 8:47. The time is increasing. With the time is increasing, right? With the time, with the time is T equals 1 second, time is 2 second, time is 3 second, time is 4 second, time is 5 second. Then what will happen for the velocity? When the time is 0, when the time is 0, what is your velocity? When time is 0, your y-axis, velocity is 0. When t equals 1 second, when t equals 1 second, what is your velocity? When t equals 1 second, your velocity will be this value. I say minus 1. When t equals 1 second, this value, minus 1. Let's say when t equals 4 second, when the time is increasing. When t equals 4 second, when t equals 4 second, when t equals 4 second, what is your velocity? Y-axis. When t equals 4 seconds, my velocity is, let's say, minus 3. When t equals 4 seconds, velocity is minus 3. Let's say when t equals 6 seconds, the time is 6 seconds. What is your velocity? I say this value is minus 10. Then what is the conclusion? The conclusion is when time increases, if not with the time, what happened to the velocity? With the time, with the time, velocity increased 0, 1, 3, 6, but in negative direction, minus, minus, minus. With the time, velocity increased in negative direction. That's why I marked that with the time, negative velocity increases. With the time, negative velocity increases. Do you understand? Do you understand what I'm saying? Now here is also what we'll take one graph. We'll take this graph. This graph. I think some of you understood. Will this graph? Now t is 1 second. This point is t equals 1 second, 2 second, 3 second. When the time is 1 second, what is your velocity? When t equals 1 second, I say velocity is 4. Plus 4 above the x-axis means positive velocities. Below the x-axis means negative velocities. When the time is 2 second, what is your velocity? I say 6. When the time is 3 second, velocity I say 9. When the time t equals 1, 2, 3, when the time is 1 second, 2 second, 3 second, when time increases, with the time, what happened to the velocity? 4, 6, 9, velocity increased. But positive velocity. With the time velocity increased, positive velocity. That's why I mentioned that positive velocity increases. See, look at the arrow, positive velocity increases. Here, look at the arrow. With the graph, positive velocity increases. Do you understand? Raise your hands up to everything is very clear. Raise your hands up to everything is very clear. Right, okay. Now put your main topic. Now this is very important, very, very important. This is in order to do this conversion only, we learn this ST and VT graphs. Now put your main topic. And I think all of you have the tudes also. Now this is the thing. Now if you didn't get the tude, then you should let me know. Then only this month, this week, I can post that one also. Right. So then put your main topic. Converting ST graphs into VT graphs. Put your main topic. Converting ST graphs into VT graphs. Converting ST graphs into VT graphs. Right. Now very carefully see. Now hereafter we can do the conversions. Very carefully see. Yes. Converting ST graphs into VT graphs. The topic. Converting ST graphs into VT graphs. ST graphs into VT graphs. VT graphs. Right. Okay. Now, right. If I draw ST graph, ST graph. Now I want to convert given ST graph into VT graph. I want to convert given ST graph into VT graph. given ST graph into VT graph. In ST graph now, I want to convert given ST graph into velocity time graph, VT graph. In ST graph, who is the velocity gradient? In ST graph, gradient is the velocity. In ST graph, gradient is the velocity. Gradient is the velocity. Am I correct? In VT graph, who is velocity? In VT graph, who is velocity? Y-axis is your velocity. In ST graph, gradient is the velocity. In VT graph, y-axis. Y-axis is your velocity. Velocity is y-axis. Y-axis in VT graph. So what is the idea? How do we convert given ST graph into VT graph? Whatever happened to the gradient, very carefully listen. Now, right, if they have given a ST graph and if they are asking you to convert into VT graph, logic is whatever happened to the gradient in ST graph. Again, I say whatever happened to the gradient in ST graph should happen to the y-axis in VT graph. Whatever happened to the gradient in ST graph should happen to the y-axis in VT graph. If I say like this, you won't understand. For an example, let's take one example. An example. An example. Example. ST graph. This is my ST graph. Very carefully listen. This is my ST graph. I want to convert this ST graph into VT graph. I want to convert this ST graph into VT graph. Right. ST graph into VT graph. I can put VT graph. Now tell me ST graph, whatever now, ST graph velocity means gradient. VT graph velocity means y-axis. Whatever happened to the gradient in ST graph should happen to the y-axis in VT graph. First of all, tell me what happened to the gradient in ST graph. Tell me what happened to the gradient in ST graph? Because gradient is velocity. What happened to the gradient in ST graph? Someone tell me. Now, when you say about the gradient, you want to mention positive or negative. Gradient, simple limb, constant or increasing or decreasing. When you explain about the gradient, you want to mention positive gradient or negative gradient. And you want to mention increasing or decreasing. Now here, acute angle. Acute angle means I explained many times. Positive gradient. Acute angle constant. Gradient, what is the idea? Positive gradient constant. You understand? Acute angle constant means positive gradient constant. Positive gradient constant. That means positive velocity constant. Positive velocity constant. Whatever happened to the gradient should happen to the y-axis. Positive velocity constant. Velocity is positive and it's constant. Who is your velocity in VT graph? Y-axis. Positive velocity. Velocity is positive, constant. A constant positive velocity. Constant positive velocity. That's it. Did you understand? Raise your hands up to everything is very clear. This is the idea. Did you understand? Raise your hands if you understood. Raise your hands. Now, what you do now, write down these things. Write down these things, and can you please give me a few minutes? Give me now. Time is 9 o'clock. You can take 5 minute break. So give me 5 minutes. I will come at 9:05 for an Argentina, I'm going out. Going out means for a reason I go out, but I'll come exactly 9:05. You take a break, come at 9:05. Okay. Yes. Yes. I'm back. Right. Okay. Now reply someone if you can hear me. Someone reply if you can hear me. Reply. Right. Okay. Now put your topic. Converting ST graphs into VT graphs and draw these two. This one. This one. Okay. It's okay even if you write in this example also fine. Finish writing up to now. Finish writing up to now. Yes, done. Now we'll write down. Red color pen is important when converting ST graphs into VT graphs. Right? Write down. When converting ST graphs into VT graphs. When converting ST graphs into VT graphs, comma, number one. Put comma and next line number one. Whatever happened to the gradient in ST graph, red color pen. Whatever happened to the gradient in ST graph should happen to the should happen to the should happen to the y-axis in VT graph. Should happen to the y-axis in VT graph. Right? When converting ST graph into VT graph, whatever happened to the gradient in ST graph should happen to the y-axis in VT graph. I hope you guys understand that important project. But when we practice more questions, you will understand the idea. And put number two and the next point, number two and write down red color pen. Whatever happened to the y coordinates in ST graph? If not, whatever happened to the y-axis in ST graph? Next point, write down. Whatever happened to the y-axis in ST graph should happen to the area of VT graph. Should happen to the area of VT graph. Whatever happened to the y-axis in ST graph should happen to the area in VT graph. Now I will explain the second point later. Second point I'll explain later. Now I hope first point you guys understood. Now take your tubes and go to the page number in that tube, linear motion tube. Go to the page number. Page number. Yes. Go to the page number 21. Page number 21. Page number 21. Question number 1. Now we'll start doing that question. Page number 21. Question number 1. Draw ST graphs for the draw VT graphs for the below ST graphs. Now we'll do it. Right? Now we'll do it, then you will understand how this happens. Yes, we'll do it. First graph ni, graph number 1. Graph number 1. ST graph, I want to convert to VT graphs. Graph number 1. ST graph. First graph is if I draw the VT graph. So don't draw VT graph this side. Always draw the VT graph below the ST graph. Always draw the corresponding VT graph below the ST graph. Draw the VT graph. Now, whatever happened to the gradient should happen to the y-axis in VT graph. Now, first of all, tell me what happened to the gradient? Gradient, angle acute. That means positive gradient Acute angle constant. Acute angle constant means a positive gradient constant. That means positive velocity constant. Positive velocity constant. Then this should happen in VT graph. Positive velocity because beyond the time axis velocities are positive. Throughout the time velocity is constant. This is your VT graph. First one is done. Second one. Second one. Graph number 2. Graph number 2. Graph number 2. ST graph. ST. It goes like this. Then I want to do the corresponding VT graph. The corresponding VT graph. Now what happened to the velocity in ST graph? What happened to the gradient in ST graph? Gradient. Acute angle. Acute angle ni? Acute angle. What happened to acute angle? Acute angle has increased. Acute angle increased. Acute angle increase means a positive gradient increased. That means positive velocity increase. Positive velocity increase. Do you understand? Positive velocity increasing. Then how do we draw positive velocity increasing graph? Positive velocity increasing graph. Positive velocity increasing graph. How do we draw this one? Now we want to draw positive velocity increasing graph. How do we draw it? What can we say about the initial velocity? Reply everyone. Now we know positive velocity is increasing. When t equals 0, by looking at this ST graph, someone tell me, when t equals 0, by looking at this ST graph, someone tell me, what can we say about the velocity when t equals 0? What can we say about the velocity when t equals 0? Someone tell me. What can we say about the velocity when t equals 0? If you want now in ST graph, if you want to check the velocity, always do a tangent line and find the gradient at the point. When t equals 0, if I do a tangent line, right? If I do a tangent line, when t equals 0, if I draw a tangent line, the tangent line is horizontal. Tangent line is horizontal. Tangent, right? So therefore, I can say when t equals 0, I can say when t equals 0, I can say tangent line is horizontal. Therefore, I can say when t equals 0, I can say gradient is 0. So therefore, I can say that velocity is 0. Do you understand? Then initial velocity is 0. When I consider initial velocity is 0 and positive velocity is increasing. Now different students can draw now. We can now. What is the condition? Initial velocity is 0. Therefore, graph should be start from this point. Positive velocity is increasing. Now different students can draw different graphs. Under the condition positive velocity increases, different students can draw different graphs. Do you understand what I'm saying? don't you misunderstand? First graph, what do you mean? Now one have asked, now this is the important thing that you want to clarify. Now one student has asked that. Now here I told you that when t equals 0, when t equals 0, I wanted to find ST graph. Is ST graph. When t equals 0, I want to find the initial velocity. When t equals 0, if I draw a tangent to the graph, tangent is horizontal, therefore gradient is 0, velocity is 0, when t equals 0. Then I realized for this graph, when t equals 0, velocity is 0. When t equals 0, velocity is 0. But look at this graph. When t equals 0, do you think? Raise your hands, how many of you say that when t equals 0, do you think? When t equals 0, do you think velocity is 0? In this graph, raise your hands, how many of you say that when t equals 0, velocity is 0? Raise your hands. How many of you say when t equals 0, velocity is 0? Raise your hands. Raise your hands, anyone? No, right? Because if you want to check when t equals 0, velocity is 0 or not, draw a gradient, draw a tangent line. When t equals 0, if I draw a tangent line has an angle. Tangent line has an angle, acute angle. What is the meaning of that? When t equals 0, if I draw a tangent line is an angle. And that means what is the idea? When t equals 0, tangent has an angle. When t equals 0, there's a gradient, there's a tan theta value. There's a gradient. It's a positive gradient. Therefore, initially, when t equals 0, there's a positive velocity. Same angle. Throughout the graph, same acute angle. No, okay, now I take time to explain because every graph you would learn something and also understand now. I can't give all the points here. Whatever you feel important when I'm explaining, whatever you feel important, write down. Write down. Okay. Now this is because different students get different feel. Different students they think no, the things important for you might not be important for another student, right? For a very bad student, he don't even write the note also. Very bad students. Whatever important, he write it. So therefore, whatever you feel important, write down in your note. Generally, what is important, I give as a note. In addition to that, whatever important for you, you write it as a note. Now I'm still talking about the second graph. I take time and I do it because there's a reason. Now in this graph, now we know that initial velocity is 0, velocity is increasing. Now one possible graph is, this is one possible graph. Am I correct? Here positive velocity is increasing with the time, positive velocity is increasing. This is one possible graph. Right, this is the one possible graph. One possible graph. Initial velocity is 0. Y-axis, look at the y-axis velocity. Look at the y-axis. Initial velocity is 0. And positive velocity is increasing. Am I correct? Positive velocity is increasing. Positive velocity is increasing. Am I correct? But one can draw another graph this way also. Do you understand what I'm saying? Now, no matter this one or this one is also initially y-axis, initially velocity is 0, positive velocity is increasing. One can draw this type of graph as well. This graph also says that initially velocity is 0, y-axis. Check the y-axis or don't check the gradient in VT graph. That's the point where you confuse. If you want to, you check the gradient to check the velocity in ST graph. In VT graph, if you want to check the velocity, check the y-axis. All three graphs have initial point is 0 velocity, velocity is increasing. So therefore, we can draw three possible graphs. Did you understand second graph? Raise your hands. How many of you understood second graph? Raise your hands. How many of you understood second graph? Raise your hands. Understood second graph. Now, after you do second graph, write an important. After you do the second graph, write an important right now. There are three possible graphs can be drawn. There are three possible graphs can be drawn. There are three possible graphs can be drawn. Acceleration. VT graph gradient is, I told you, acceleration. Here gradient is acceleration, I told you. That's the thing now. You go after class finishes, rewatch the recordings again or go to the notes again. The VT graph gradient is acceleration. Don't think about gradient. Okay, what I told, there are, someone tell me what I told, there are three possible graphs that can be drawn. There are three possible graphs that can be drawn. There are three possible graphs that can be drawn in such a way that, in such a way that, in such a way that there are three possible graphs that can be drawn in such a way that positive velocity increase, positive velocity increase, positive velocity increasing manner. Positive velocity increasing manner, there are three possible graphs that can be drawn. You understand? Positive velocity increasing manner. As zero initial velocity, positive velocity increasing manner, there are three possible graphs can be drawn. I think you guys understood. Now, please write down these points also. Now, you don't think these are not important. Don't think like that. Write down these points also. Now, graph number 3. Next graph. Did you understand? Raise your hands. Did you understand? Up to now, everything is clear. It's very confusing, but every graph you will learn something. But every graph you will learn something. Did you understand up to now? Raise your hands. Right, okay. Now, graph number 3. Graph number 3. Next one. Graph number 3. Right. Graph number 3. Displacement. Displacement. Now, this time your graph is this way. Right? Then how do I draw the VT graph? How do I draw the VT graph? How do I draw the VT graph? VT graph. How do I draw the VT graph? So what's happening here? What's happening here? Here, acute angle. Again, acute angle. What's happening to the acute angle? Acute angle is decreasing. Acute angle decreasing means positive gradient decreasing. Positive gradient decreasing. Positive gradient decreasing means positive velocity decreasing. Positive velocity decreasing. When t equals 0, check the velocity. When t equals 0, if you want to check the velocity, when t equals 0, when you draw tangent line, ST graph, I'm talking about ST graph. When t equals 0, if you draw tangent line, there's an angle. That's an angle theta. That is when t equals 0, when you draw tangent line, that's an acute angle. When t equals 0, the theta is acute. The theta is acute. That angle is acute angle. There's an acute angle. Theta is acute angle. Acute. So therefore, what can I say? Therefore, theta is acute. Tan theta is positive. Tan theta is positive. Tan theta is positive. Therefore, positive velocity when t equals 0, this object is having positive velocity. When t equals 0, object is having positive velocity. What should happen for the positive velocity at the time? That positive velocity is decreasing. When t equals 0, object is having a positive velocity. That positive velocity is decreasing. Decreasing. When t equals 0. Right? Object is having some kind of positive velocity. Object is having some kind of positive velocity. I say this velocity. Positive velocity. Some kind of positive velocity. That positive velocity is decreasing. That positive velocity is decreasing. So why do we want to consider gradient in second graph? Because why do we want to consider gradient in second graph? Because what I told is check the gradient in first graph. Follow what I say. I told you that check the gradient in first graph. And according to that, look at the y-axis in second graph. Check the gradient in ST graph and draw the graph by looking at the y-axis. You don't need to check anything about second. I don't understand. I didn't understand that's a question. Don't you confuse this, okay? That's the important thing. If you confuse this, it's a problem. Okay, don't you confuse this one. Now, right. Because no, now you might now. I will tell one important point because now look here. When I take time to explain. Right, I take time to explain because look here. Now the problem is that why we are getting three possible graphs. You know why? Why we are getting three possible graphs? The reason is now by looking at this ST graph, roughly, very carefully listen. If they have given a rough sketch, if now without mentioning about the coordinates exactly, this is important point. Okay, very carefully listen. Now they have given only the rough sketch of ST graph. S and T axis. This graph is like this. By looking at this graph, understand we can get a rough understanding about velocity. By looking at this ST graph, understand we can get what's happening to the velocity. Whether velocity is now we understood positive velocity is increasing. By looking at this rough graph, we can understand that object is moving in positive direction. Therefore, positive velocity is increasing. But understand positive velocity can be increased in three different ways. Okay, look here. Positive velocity can be increased. Now, what is the conclusion from first graph? You conclude that positive velocity increases. But understand positive velocity can be increased in three different ways. Positive velocity can be increased in three different ways. Positive velocity can be increased under constant rate. Positive velocity can be increased under constant rate. Now, what does it mean by positive velocity increasing under constant rate? If you have a good understanding about whatever I taught you before, acceleration, everything, specifically if you know the idea of acceleration, positive velocity increasing under constant rate. Anyways, positive velocity increasing means that object is undergoing acceleration. Anyways, positive velocity increasing means that object is undergoing acceleration. Positive velocity increasing under constant rate means what is the idea? positive velocity increasing and constant rate is the idea. Acceleration is constant. Acceleration is constant, not zero acceleration. Zero acceleration means a constant velocity. Zero acceleration means constant velocity. But here I'm talking positive velocity is increasing at the constant rate. That means acceleration is constant. I don't know how many of you can understand. That's why I don't teach this much deep. Acceleration is constant. Constant. Positive velocity can be increased at an increasing rate. At an increasing rate. At an increasing rate. You don't need to understand this much of deep. That's why I don't teach these things. Positive velocity can be increased under increasing rate. Now, someone tell me what is the meaning of positive velocity increasing under increasing rate? Someone tell me. Someone tell me what is the meaning of increasing rate? Positive velocity increases under increasing rate. What is the meaning of that? Acceleration is increasing. Now, always understand if an object is having an acceleration, if an object is having acceleration, velocity is obviously increasing. But even if now let's say now there's a car, that car is moving under 5 ms minus to constant acceleration. 5 ms minus to constant acceleration. Even though acceleration is constant, but that's an acceleration. Therefore, velocity of the car is keep on increasing. Another case, that acceleration of the car is keep on increasing. Acceleration is keep on increasing. Right? Very careful understand. If that car acceleration is also increasing, means velocity is rapidly increasing. When the acceleration is constant, then also velocity increasing. When the acceleration is increasing, obviously velocity is rapidly increasing. When the acceleration is decreasing, now I don't know how many of you sensitive for this. When the acceleration is decreasing, when the acceleration decreasing also, velocity is increasing. Because even though acceleration is decreasing, somehow there's an acceleration. When the acceleration decreasing, somehow object is having some kind of acceleration, therefore velocities keep on increasing. That's why I told that velocity can be increased under 3 different conditions. Under constant rate velocity can be increased, under increasing rate velocity can be increased, under decreasing rate velocity can be increased. Velocity increasing under constant rate means constant acceleration. Then there is the graph. Now I told you there are 3 possible graphs. I told you there are 3 possible graphs. The reason, you know, why I drew 3 possible graphs, because I can't predict from this graph. Only data that we can collect is from this graph. Only data that we can collect is positive velocity increases. Other than that, we can't collect exactly positive velocity increasing under constant rate. Positive velocity is increasing under increasing rate. Positive velocity is increasing under decreasing rate. We don't know. The given this graph is not sufficient to find this positive velocity is increasing under what rate. That's why I told you there are 3 possible graphs. Suppose, okay, this is not important. Suppose if positive velocity increases under constant rate, that means acceleration constant. Vt graph gradient is acceleration. Vt graph gradient is acceleration. Then constant acceleration means this is a graph. If they mention positive velocity increasing under constant rate, then this will be the graph, the right one. Suppose if they have mentioned positive velocity increases under increasing rate, that means acceleration also increasing. Vt graph gradient is acceleration, acceleration also increasing. In that case, this will be the graph. I don't know how many of you understand, but this is not that much important thing. We don't need to dive into this much deep, but someone asked a related question, that's why. Positive velocity increasing and decreasing rate. Now here acceleration is increasing. Inside the bracket, acceleration increasing at an increasing rate. It's really confusing subject, but you go to the recordings again, then everything will be solved. Okay, you don't worry, don't afraid. Don't afraid if you could not understand one important point, don't you afraid. At a decreasing rate. That means acceleration is decreasing. That means this will be the graph. Now, anyways, right? Anyways, okay, I will give a small note, but this note is not important. I didn't have any idea of giving this note, but anyways, okay, I will give a note, right? After you drew this graph, now there are three possible graphs. Now we'll name this blue color one is graph number one. This one is graph number two. This one is graph number three. We'll name graph number one, two, and three. But it's not important that much. It's not important, right? Now, I think you guys drew this. Draw this one. This one. This one. If you finished writing this one, raise your hands. I will give a small note. If you finished writing, raise your hands. If you finished writing, raise your hands. If you finished writing, raise your hands. Okay. Right. Okay. Now it's not important, but from this ST graph, write down. From this ST graph, from this ST graph, the only conclusion that we can obtain is positive velocity increases with the time. The only conclusion that we can obtain is positive velocity increases with the time. Right. Under that condition, under positive velocity, right, plus V arrow up, under positive velocity increases condition. Under positive velocity increases condition, there are three possible VT graphs. There are three possible VT graphs. There are three possible VT graphs. Number one, suppose positive velocity increased under constant rate. Suppose positive velocity increased under constant rate, comma, motion is constant acceleration motion. Motion of the object is constant acceleration motion. Motion of the object is constant acceleration motion. Right. So then this is the graph, because VT graph gradient is acceleration. VT graph gradient is acceleration. Now acute angle constant, positive gradient constant, positive acceleration constant. Now second graph, acute angle increasing. That means positive acceleration increasing. Now here acute angle decreasing, acceleration decreasing. Now next second one, number two, suppose positive velocity increased at an increasing rate. Suppose positive velocity increased at an increasing rate, comma, Motion of the object is increasing acceleration motion. Motion of the object, but this is not important. Don't you confuse everything. But the motion of the object is increasing acceleration motion. But in your exam, if you draw any of them, if you draw any of the graph, they will give marks. Right? If you because I told you now, when one some people they draw like this. One student might think this way. One student might think that way. I want to tell any way is correct because we are not very clear about how this velocity is increasing. That's the thing. I don't know how many of you get what I'm saying because if, when we teach more deep, students they don't understand. That's the problem. When you go so deep, they don't understand. So therefore, I usually I go somewhat deep and I explain everything the right way. But I am somewhat afraid when I go deep. I don't know how many of you understand. Not important. This is not important. Okay. Case number next one 3. Suppose positive velocity increased under decreasing rate. Under decreasing rate, comma. Uh, Motion of the object is decreasing acceleration motion. Motion of the object is decreasing acceleration motion. That's it. Okay, that's it. Forget about that one. Okay. Now raise your hands. Did you really understand up to now? Everything is very clear. Did you really understand? Raise your hand. Did you really understand up to now? Everything is very clear. Right. Okay. I hope you guys understand. Okay. I hope you guys understand. Right. Okay. And now we'll go to third graph. Okay. We'll go to third graph. Now we have to do. We'll go to third graph. A third graph. I forgot about these things. Forgot about the story. Third graph. What happened when t equals 0? Object had a velocity and positive velocity is decreasing. Positive velocity decreasing. Right. Then I can draw positive velocity decreasing. Now, if we assume now when you go to the tube in that tube, when you look at the third graph, that third graph seems like look every graph. I want to teach you something. But again, we'll write one important point. Okay, every graph because from every graph we want to learn something. Now, okay, you also draw this with me. Also draw with me. ST graphs. There are two ST graphs. Okay. There are two possible ST graphs. Important point. Okay, put important point and draw these two graphs. But I don't think that no one explains in this way. I'm very confident. I think you might have gone for some classes. I know that. I think none of think there may be some teachers, but no one explains in this level, right? If you really join for a class, not for entertainment, but to really learn, I think this is one of the best class. Few some students they join for classes to get the entertainment. They are eagerly waiting for teachers, jokes, and that type of shits. Because I'm very weak in joking, you know that. So therefore, if other than joking, if someone is coming for a class to really learn what's happening in the physics, then I think this is the best class, right? Okay, right. Now I'm going to explain this graph. There are three possibilities. There are two possibilities. Okay? So you might meet two different graphs. Seems like very same graph. Now this graph, first graph is, if I draw the first graph, this first possible graph. Second graph you will obtain this first possible, these are two seems like same graph, seems like same graph, but understand there is some kind of difference, right? Now, as usual, same idea, acute angle. Acute angle is decreasing. Anyone can understand me? Acute angle decreases. Acute angle decreases means positive gradient decreases. That means positive velocity decreases. Both the graphs, we know that positive velocity decreases. This graph is also same. Positive velocity decreases. Now, someone tell me now, okay, if you can already predict that, someone tell me what is the main difference between these two graphs? If you understood the main difference between these two graphs, someone tell me what is the main difference between these two graphs? What is the main difference between these two graphs? Main difference. Main difference. No, this is just uh, okay. Now think now. Okay, now displacement is also thing same. These two heights also same because I could not draw in the same way. I could not draw in the same way. Okay. Want erase. Okay, right. Okay. Now think these two heights are same. Then displacements are same. Thinking that way. Other than that, what is the main difference? What is the main difference? Not the displacement. Okay, forget about okay. Oh, both of you told displacement same. Right. It's difficult to draw, man. Uh, it's difficult. Okay, shape. Somewhat okay. Both of them have same initial same angle. Don't you misunderstand? Both of them have same angle, initial angle. What is the main difference between these two? Main difference is final velocity. After simple t time, main difference is final velocity. Check why. Now when t equals 0, when t equals 0, I want to check the velocity. If I draw a tangent line at 0, the angle is theta. The angle is theta. Then I can say that when t equals 0, I can say when t equals 0. I can say when t equals 0, uh, there's an acute angle. Theta angle is acute. Acute. So therefore, I can say that when t equals 0, gradient tan theta is positive. Therefore, gradient is positive. When t equals 0, object is having a positive velocity. So when t equals 0, object has a positive velocity. Object has a positive velocity, right? The same thing in here is also okay. When t equals 0, I take time and explain when t equals 0, if I draw a tangent line, same angle, okay, same angle theta, same angle theta. Then same thing you can write on here also. When t equals 0, when t equals 0, theta is acute. So therefore you can say tan theta is positive, gradient is positive, velocity is positive. When t equals 0, object has a positive velocity. When t equals 0, object has a positive velocity, right? Now, important thing is what can we say about the velocity at simple t time? If I draw a tangent line at simple t, if I draw a tangent line simple t, tangent line simple t, the angle, this angle I say theta 2, this angle is theta 2. When, look here, if I say this initial velocity as v1, positive velocity, initial velocity is I say v1. Look here, when the time is t equals simple t, when the time t equals simple t, again the tangent line has an angle, acute angle, theta 2, that is acute. Then tan theta 2 is positive, gradient positive, velocity I say v2, this velocity I say v1, okay, velocity positive. When t equals 0, look here, when t equals simple t, object has a positive velocity. Object has positive velocity v2. Now someone tell me, very carefully listen, when t equals 0, velocity of the object is I said v1. When t equals simple t, velocity of the object is I said v2. Raise your hands, how many of you say v1 is larger than v2? Raise your hands, how many of you say that v1 is larger than v2? Raise your hands, how many of you say v1 is larger than v2? It's all about logic. Yes, v1 is larger than v2 because why? Acute angle is reduced. Acute angle reduced means what? Now I say this angle is theta 1. We'll take this angle is theta 1. If I won't write down below, but I write up. Now theta 2 is smaller. That means acute angle. These are acute angles. So therefore I can say that acute angles. Therefore I can say that tan theta 1 is larger than tan theta 2. Gradient larger than m2. Therefore I can say velocity v1 is larger than v2. v2. But when you consider this graph, now when I do a tangent, when the time is simple t, when I do a tangent, when the time is simple t, what can we see about the tangent line? That's horizontal. See, even now they can give a graph by point out this type of very tiny important things. Now students, they don't understand the difference between these two graphs. That's how they ask question in the exam. Students think that okay, these two graphs are same and they don't get the right logic. Now here, if you do a tangent, there's a tangent line that has an angle, but in here, tangent line is horizontal. What is the conclusion? The time is simple t, gradient is 0, velocity is 0. So when t equals simple t, when t equals simple t, theta is 0. So therefore velocity is 0. That's the difference. You got what I'm saying? Did you really understand the difference between these two graphs? Did you really understand the difference between these two graphs? Did you really understand the difference between these two graphs? Raise your hands. If you understood, raise your hands. Raise your hands. Write down. Copy down. Copy down, because every graph we want to learn something. Then after what you want to do, you want to prepare a short note, right? It's very important. Always I say that after class finishes, even though I say I don't say it's your responsibility. After class finishes, take a break. Now have your lunch, have your dinner, and wash your wash your face. So take a wash, and then again sit in the chair and start just revise what you learned today itself. That's important. After this motion graph section entirely covered, take large piece of paper, that half sheet, take one half sheet and write down all the short points, important points. It's just short, right? Because you know that sometimes how many pages have you completed up to now in this motion graph section? Whatever important, whatever the tiny and important points, bring them into a small, full half sheet. Then when you go for your exams, especially first term test exams, you don't need to go through your notebook. Even with the hurry, when you refer the note, sometimes you don't get the right idea. But if you have the short note, then all the important points are there. Though, because usually we forget the important points. Now we have an understanding. This T graph, VT graph, we know, but the thing is we forget the important points. If all the important points are nicely categorized, nicely mentioned in a what uh, half sheet paper, it's really beneficial. Some students they follow what I say in 24 batch, many following. Now when you consider my paper class, they are the tops. They are always top because people who follow what I say every day. If I say to do this, there are some girls, mostly girls. Boys they do, but me, mostly there are many girls. They are scoring always high marks because why? Since 1.5 years, they followed what I taught every time. Sometimes they send the homework 1:30 a.m. Sometimes I have physical classes. Then Monday, Bambalapitiya, I do a physical class. Then after class, because morning they have schools, MLC, mostly MLC girls, mostly they go school. Then Monday evening they join for the physical class, Bambalapitiya. After that, because I am somewhat a strict person, then I give homeworks. They want to complete the homework in the same day itself. There are some girls, they do it, it's very tired. For me also very tired. After I teach and after I go home, I'm very tired. I also feel, I also sleep. But those people who want to go for a result, they don't mind about the tiredness. And they every day, because one more than 1 year, I'm noticing them. Even though how much they tired, they do the homework, they do the short note, they do the paper that I ask them to do, and they send me as a PDF only. They take their rest. So therefore, you also do the same thing, right? That's the important thing, right? That's the important thing. Okay, uh, do it quickly. Write down quickly. Then start doing next question. Next one. The fourth one. And then the right answer, you know that now. Now in the diagram, in third one, the graph is not like this. Graph seems like this. Graph seems like this. So therefore, even when the time is simple t, even the time is simple t, even the time is simple t, this object is having some kind of velocity. Even the time is simple t, this object is having some kind of what? Velocity, positive velocity. So therefore, your graph will be some positive velocity decreasing. You got it? It can be this type of graph. If not, as I mentioned, one can draw this type of graph. This type of graph, right? So raise your hands up. Everything is very clear. Everything is very clear. Did you understand? Start doing next graph. Graph number 4. Graph number 4 quickly. Start doing next graph. Start doing next graph. Graph number 4. Raise your hands. How many of you started drawing the graph? Raise your hands. Started drawing the graph. Quickly. Quickly. I think we are able to finish this graph section mostly in the next day. I think idea is done. We can finish this graph section in one day. Then motion graph conversions will be completely covered. Sometimes we might need one more day to cover the graph entirely, because conversion section can be covered on next day fully, converting ST into VT, the remaining things, and VT to ST, and then converting VT to AT, again AT to VT. Those things will be covered on next day. And also we might need one more day to cover now the remaining section in the motion graph. And this is completely finished. A long section, right? Do it. Sometimes if I feel it's important to do some kind of additional class, I will inform before next Tuesday. Sometimes even the Tuesday morning, sometimes maybe, I'm not sure. I might do an additional class. It's not important. Not important, but because we are in some kind of plan, therefore I might do an additional class. I will exactly let you know what is the plan. Okay, right then I will stop right now, and we'll meet on next day. But my advice is do them again. It's very important. So always do them again. And if you have any doubts, feel free to ask your doubts and everything. We'll stop for today, right? Okay, we'll stop for today.